Welcome, my friends! I'm so excited because in this video we get to talk about the one sample proportion hypothesis test. So let's go ahead and get started. Just like the last video, I'm going to be referencing the Chapter 8 Hypothesis Testing Main Ideas handout. So if you'd like to have a copy of this, the link is in the description. So we're going to be following the same 3 steps that we did in the last video. Step 1, set up the hypotheses. Step 2, do the calculations. And step 3, decision and conclusion. But now we're going to be doing the second row, which relates to the one sample proportion. Recall that if we have categorical data, we can't calculate the mean. For example, suppose that 20 out of 100 randomly selected Michigan high school students say that math is their favorite subject. The variable of response to the survey question, as either yes or no, is categorical. The most common way to summarize categorical data is to calculate the proportion or percentage of successes to the total sample size. So to calculate the proportion of Michigan high school students sampled whose favorite subject is math, we can take x, which represents the number of successes, and divide by the sample size. We will get 20 divided by 100, which is equal to 0.2 or 20%. Which is our sample proportion, or p-hat. Sometimes we might have a hypothesis about the value of a population proportion p. In this section, we will use the same 3 steps to complete a hypothesis test on the population proportion. Recall the difference between left, right, and two-tailed tests. There will be some claim in terms of the population proportion that you would like to challenge. If you believe that the true value is smaller than what has been stated, you have a left-tailed test. If you believe it is larger than the value that's been stated, you have a right-tailed test. And if you believe it is somehow different from the value that has been stated, you will have a two-tailed test. No matter which case you will have an equal to sign in your null hypothesis. All that's going to change is the sign in your alternative hypothesis. If you have the left-tailed test, where you believe that the proportion is smaller than the value that has been stated in your null hypothesis, you will have the less than sign. You will end up finding a p-value in the left tail of the distribution. In this case, we will be using the z distribution. We could also have a right tail test if you believe the value of the population proportion was greater than the value stated in the null hypothesis. In that case, you would be finding a probability or p-value in the right tail of the distribution. The third case is the two-tailed test, where you believe the value of the population proportion somehow differs from the value stated in the null hypothesis. In that case, you will be finding a p-value that is the combined value of the probability in each of the two tails of the distribution. In practice, you typically find one of those probabilities and multiply it by 2. The assumptions for the one sample proportion hypothesis test are, number 1, you must take a random sample, and number 2, the quantities n times p and n times q should be both at least 5. This ensures that the distribution of your sample proportion will be approximately normal based on the central limit theorem. N, of course, is your sample size, and p is your hypothesized value for the population proportion. Q is the complement of p, or just 1 minus p. In step 2 of the hypothesis test, we will have to calculate a test statistic. We will use this formula for the z-score in order to find our test statistic. P-hat in the formula is the proportion of successes from your sample. You will need to calculate this by taking x, the number of successes from the sample, and dividing by n, the sample size. X would be like the number of individuals who liked math from your sample, and n would of course be your sample size. P is your hypothesized value for the population proportion. This will be a value that has been stated in the problem. You will not need to calculate this value. Q is the complement of P, which is the hypothesized proportion of failure. Let's take a look at an example. Grand Valley State University claimed in a 2015 report that 94% of their graduates are either employed or attending grad school. You think this number sounds too high for today's job environment. You survey 400 randomly selected GVSU graduates and find that 368 are either employed or in grad school. Is there sufficient evidence to suggest that fewer than 94% of Grand Valley graduates are either employed or in grad school? Use alpha equals 0.01. The first thing you should do is write out the given information. The claim in terms of the population proportion is that it is equal to 94%. So that is p equals 0.94. To test this claim, we took a sample of 400 individuals, so our value for n is 400. From those 400 individuals, 368 were either employed or in grad school, so our value for x is equal to 368. From these numbers, we can calculate our sample proportion, which is 368 divided by 400, or about 0.92 or 92%. This says that 92% of the individuals from our sample were either employed or in grad school. Next, we can go ahead and set up the null and alternative hypotheses. Once again, use the handout as a guide. The null hypothesis for the one sample proportion test is that p is equal to some value. In this case, p is equal to 0.94. So our null hypothesis will be that p is equal to 0.94. Our alternative hypothesis must have one sign that is either a less than, greater than, or not equal to sign, depending on what we are trying to test. If we have a less than sign, we will have what is called a left tail test. The greater than sign will indicate a right tail test, and the not equal to sign will indicate a two tail test. In this problem, they say, is there sufficient evidence to suggest that fewer than 94% of the Grand Valley grads are either employed or in grad school? So the word fewer is indicating a left-tailed test, so we'll use the less than sign. Next, we can go ahead and do our calculations, step 2. The first part of the calculation step is to find the test statistic. To find the test statistic, we can once again look back at our sheet and find the formula for the test statistic. For the one sample proportion hypothesis test, the test statistic can be found by this z-score formula. Let's plug all the numbers into the formula. We have p hat, which is equal to 0.92. We have p, which is 0.94. P is here again at 0.94, and I've plugged in Q as 1 minus 0.94. That would be like the 6% who are not employed or in grad school, and divide by the sample size of 400, and apparently we get negative 1.68 when we plug that in. Let me show you how I would plug this into the calculator. So for the numerator, make sure you open parentheses, put 0.92 minus 0.94, divide by the square root of 0.94, and then I could either multiply by 0.06, or I can literally just type in the Q as 1 minus 0.94, and then divide that by 400. And if we've done this correctly, we should get approximately negative 1.68 as our answer. Typically, I will round this to 2 decimal places. Next, we need to find the p-value. In order to find the p-value, you're always going to want to draw the distribution. In this case, we have a z-distribution, which has a value of 0 in the middle. Our test statistic of negative 1.68 should go somewhere to the left. Since we have a left-tail test, indicated by the less than sign, we are trying to find the probability that we have a z-score that is less than negative 1.68. Once again, we can go back to our sheet here, and we can see that the proper way to find this p-value would be with a function that is called normal CDF. To find normal CDF, we would go to our calculator, and we would go to the second distribution menu, and scroll down to the second option, which is normal CDF. The lower bound is where the shaded region starts, but in this case, there really is no starting point. It goes forever in the negative direction. So I'm going to use negative 1000 to represent negative infinity. For the upper bound, we use, well, wherever the shaded area ends, which in this case is at negative 1.68. Always leave mu and sigma at 0 and 1 for the mean and standard deviation of the standard normal z distribution. Go ahead and paste, press enter, and we'll get the p-value of about 0.0465. Once we have the p-value, we can go on to step 3, which is decision and conclusion. To make a decision, we will compare the p-value to the level of significance, which in this case is 0.01. Our p-value of 0.0465 is greater than 0.01. So as the saying goes, if the p-value is high, the null will fly, which means we are going to fail to reject our null hypothesis. Once again, if you are struggling with remembering some of these sayings here, I got the saying right here, as well as the hypothesis testing rule. So in this case, the p-value was greater than that level of significance, so we are not going to reject our null hypothesis. Finally, we can write our conclusion. The conclusion should come in this general form, which I have right here. In this case, will look something like this. At the alpha percent level of significance, in this case the 1% level of significance, because that is what they stated right here, there is not enough evidence, right? We're going to say is not when we fail to reject our null hypothesis, which is what we did here. So we say there is not enough evidence to suggest, and then we should describe our alternative hypothesis in words. Our alternative hypothesis is that p is less than 0.94, and that's what I've stated here, to suggest that fewer than 94% of Grand Valley graduates are either employed or in grad school. And that is the end of our problem. All right, here is a problem for you to try. A new experimental medication has been designed to regrow hair in middle-aged adults. Under the most popular medication currently on the market, only about 40% of individuals regrow their hair. From a random sample of 150 individuals who received the new medication, 78 regrew their hair. Is there sufficient evidence to suggest that the new medication is more effective than the old one? And we're going to be using a 5% level of significance. So go ahead and see if you can write down the given information, calculate your p-hat, and then from there you'll want to set up your hypotheses, and then you will want to calculate the test statistic and p-value, make a decision, and then write a conclusion. So take a minute to try to do those steps and get as far as you can. I will be back in just a moment to help you through some of those steps if you get stuck. All right, I'm back with some of the work. There was a claim that 40% of the individuals were going to regrow their hair with the old medication. So that's a value that is a statement in terms of the population proportion P. P equals 0.4. We had a sample size of 150, and from that we had 78 individuals regrow their hair. So X, our number of successes, is 78, and our sample size is 150. We can divide these two numbers to find our sample proportion, which ends up being 0.52, and they also state that the level of significance is 0.05. You could also calculate Q, which would be 1 minus P, or 0.6, but I have not written that down here. Then we need to set up our null and alternative hypotheses. Our null hypothesis is going to be that P is equal to 0.4, and our alternative is going to depend on the statement that they have here. They say, is there sufficient evidence to suggest the new medication is more effective than the old? So that would be P is greater than 0.4. From here, you can go ahead and set up your, calculate your z-score using this formula. So plug all the numbers in here. And then once you have done that, you will get a z-score, and you can go ahead and draw your distribution. You will get some z-score over here, whatever your z-score is, and you'll be trying to find the probability you are greater than that. So you'll use the normal CDF function to find that p-value. Once you find the p-value, you'll want to make a decision and write a conclusion, and then you will be finished with the problem. All right, that's all I had to say here in this video related to the one sample proportion hypothesis test. Hopefully you found it useful, and I will see you in the next video.